We finished Unit 6, so we're ready to look at the practice test. All the normal instructions here, write your answers in the correct form and things like that. We've got the graph of f given right here, and it says sketch the new function given the transformation. So on number 1, here's the transformation, and we want to sketch this transformation over here. So we're going to take this graph, do those transformations to it, and then sketch them right here. Now, I'm going to try and do this in a couple different ways, one of which may make more sense to you depending on how you think of this and stuff like that. But the first thing that everybody ought to be able to do is take a look at this and say what each one of these did. Remember, because this is an x plus 2, that plus 2 is with the x in parentheses. We change the x before the function makes the shape, so it changes it in a horizontal direction. And remember, horizontal changes do the opposite of what we'd think. So it doesn't move it to the right 2 units. This actually moves it to the left 2 units. And then minus 3 outside that function after it makes the shape. That's a vertical change. It does exactly what you'd think. If we're going to move this vertically by subtracting 3, this is going to move the graph down 3 units. Now, we could go through and we could take every one of these 4 key points. There's only 4 key points on this one right here. And we could take them and we could move them around. But I'm going to do something that's a little bit different. I'm going to take each one of these points and I'm going to perform these transformations coordinate by coordinate. I'm going to change the x coordinate and the y coordinate and see if this works out with what we'd get if we were to graph this. So I'm going to take this point right here. This is negative 4, 2. So negative 4, 2. This point right here is 0, 2. This point right here is over 2 and up 1, so that's 2, 1, and then this one is 3, 4, so 3, 4 right there. Now there's space on this one to put another one, but we don't need that. There are only 4 key points right here. So we're going to take each one of these, and I'm going to do this coordinate by coordinate. So if I'm going to take the x coordinates, I'm going to move those left 2. Here's what I need to do. I need to take each one of these, and I need to subtract 2 from it. If I'm going to take the y coordinates and I'm going to move them down 3, I'm going to take each one of these function values and I'm going to subtract 3. So here's what happens if I do that. If I take this and I subtract 2 from it, I get negative 6. If I take 2 and subtract 3 from it, I get negative 1. Let's do the same thing on this one. So we do 0 minus 2, that's negative 2. 2 minus 3 is negative 1. Then we're going to do 2 minus 2, that turns out to be 0. And then I do 1 minus 3, that's going to be negative 2. And then the last one, we'd have 3 minus 2, so that's going to be a 1. And then 4 minus 3, that's going to be a 1. So we get those points right there. Now, I'm going to come up here and I'm going to graph these. So let's check and see. We get negative 6, negative 1. So back 6 and down 1. So that would be right here. And then we get negative 2, negative 1, back 2 and down 1. Whoops, back 2 and down 1. There we go. And then 0, negative 2, don't go right or left, just go down 2. And then 1, 1, over 1 and up 1. So I'm going to go ahead and connect these right here. And I think, because I did that coordinate by coordinate, I think I got that right. Now, does it look like the exact same shape, just moved left 2 and down 3? Well, it kind of does to me, but let's just do this. And again, we could have done this first and then filled out the table, but again, you don't even have to fill out the table if you don't want to. It does just say graph in the instructions. So let's take this point and let's move it left 2 and down 3. So left 2, 1, 2, down 3, 1, 2, 3. So that would put us right here, and look where we are. We're right where we'd expect. Take this point right here, left 2, down 3, right where we'd expect. Okay. Next one, back 2, down 3, right there, just where we expect. And left 2, down 3 would put us right here. So this definitely is the right graph. Again, if you want to use the coordinates to do the rules, that tends to be a little bit on the tedious side. I find it easier just to take the points and do it graphically, but this is a very good skill to have. So let's go ahead and take a look at the next one. This right here is a vertical stretch. So I'm going to write V stretch. Okay, it's going to make things 2 times taller. 2 times taller. So it's going to make this a steeper graph, taller graph. X minus 1, remember changing the x, that does the opposite. So this is going to go to the right 1 unit, right 1, and then the plus 2 outside the parentheses, that's after it's made the shape. So this is going to move it up 2. So here's what we're going to do. I'm going to come over here and I'm going to trace each one of these. I'm going to do this one graphically. So I'm going to take this and I'm going to make them twice as tall. So I'm going to make this twice as tall, so that's going to be right here. It used to be at 2, now it's at 4. And now I'm going to go right 1 and up 2. So right 1 and up 2. So that's going to put me right here. That's going to be at negative 3, 6. So negative 3, 6. And notice they changed this so we could kind of fit the graph up here when we moved it up. Okay, let's do this next one. We want to make this twice as tall, so twice as tall as it used to be. So it was at 2, we're going to make it twice as tall. And then we're going to go to the right one and up 2. So twice as tall, right one and up 2. So we'd be right here. So that would be 1, 6. So over 1 and up 6, so we'd be right there. And then we're going to do this one. We need to make it twice as tall. Twice as tall as 1 would be 2. And then we're going to go right 1 and up 2. So we happen to end up right there. That would be 3, 4. So over 3 and up 4. So we're going to be right there. And now we'll do the last one. This one here is, let's see, we're going to make this twice as tall. Ooh, so twice as tall as 4 would be up here at, that would be at about 8. And then we're going to go, let's see, we've got to go right 1 and up 2. So that's going to be over here at, we were at 3, so this is going to be 410, I think. Yep. We were at 3, move over 1, that would be 4, and then up 2, that would be 10. Okay, so 410. Okay, so that makes sense as to why they did that. So let's go ahead and connect these, and let's make sure that this looks right. Okay. Does that look like the original graph, but it's been made twice as tall, or in other words, twice as steep? You can see that that line's a little bit steeper, and this one's a little bit steeper. So yeah, it definitely looks taller. It used to only be from top to bottom 3 tall, but now it's 6 units tall. And it definitely looks like it's been moved over and up just a little bit. Okay, now again, if we wanted to go through and we wanted to make each one of these y values twice as tall, and then take each one of them and change them by moving the x-coordinate to the right and then the y-coordinate up 2, we could do that. So I'm going to go ahead and get rid of this, and let's go ahead and I'll show you that it works coordinate-wise also. So I've got this set to go. Here's what we're going to do first. We're going to make all of those y values twice as tall. So I'm going to take each one of these and I'm going to double them. So this is going to be 4, that's going to be 4, that's going to be 2, and that's going to be 8. Now I'm going to go ahead and lightly cross those off because these are the new x and y coordinates. And now what I need to do is I need to move these right and up. So I need to add 1 to every one of these x coordinates, and then I need to add 2 to every one of the y coordinates. So if I do negative 4 plus 1, that's going to be negative 3. And then again, not the 2, but the 4. 4 plus 2, that's going to be 6. And then we're going to do 0 plus 1, so that's going to be a 1. And then 2 plus 4, that's going to be a 6. And then we're going to add 1 to this, so that's going to be a 3. And add 2 to the 2, so that's going to be a 4. And then add 1 here, so that's going to be 4. And add 2 to the 8, that's going to be a 10. Now again, this is a little bit tedious, so we just want to make sure that this works. So let's go ahead and check these endpoints right here. Do we have a point at negative 3, 6? So back 3 and up 1, 2, 3, 4, 5, 6. There we go right there. And let's check the other end. That'll be good enough. 410 over 4 and up 10. There it is right there. So this coordinate business works also. If you want to do it graphically, which I think is easier for most people, you're welcome to do it that way. So let's speed this up just a little bit. Let's do each one of these graphically. So this is going to be a horizontal flip. Horizontal flip. Okay, and then this is going to make them half as tall. Half as tall. So we've got horizontal here and we've got vertical right here. This is a vertical shrink actually. So let's take each one of these points and let's do this to them. So we're going to horizontally flip them and then we're going to make them half as tall. So if I horizontally flip this, instead of being at negative 4, 2, it's going to be over here at 4, 2. And now I need to make it half as tall. So if I made it half as tall, that would be right here. So we're going to go over here to 4, 1. Okay, so there's that point right there. Next one, and again, I'm kind of going from left to right so I can kind of keep track of stuff. If I do a horizontal flip on something that's on the y-axis, it's right in the middle. It's not a right or a left, so I don't need to go anywhere, but I do need to make it half as tall, so this needs to be at 1. So we're going to put that right there. I need to do a horizontal flip on this one, so instead of being at 2, we're going to be at negative 2, and I need to make it half as tall, so that's going to be at a half, so negative 2, and then just a half. And then this one right here, we're going to make this horizontal flip. So we're going to flip over here to negative 3 for an x-coordinate. And we're going to make it half as tall. If it used to be at 4, we're going to make it half as tall. That's going to be at 2. So we're going to be at negative 3, 2. So back 3 and up 2. So let's go ahead and draw this. And hopefully we can tell what happened here. Does this look like it's been horizontally flipped, right for left? Definitely, because it kind of points the other direction. And is it half as tall? Is it half as steep as it used to be? Definitely. That one looks pretty good. Again, the graphic approach for these tends to work pretty quickly. So let's take a look at this next one. Let's see. This is going to be a vertical flip. Vertical flip. So it's going to flip it upside down. This is going to move it down 3. And remember, what happens when we multiply the x by a half? Well, what happens there is it horizontally stretches it out. Okay, it's a horizontal stretch. Remember, these do the opposite of what you'd think. You would think it would shrink it by a half. It doesn't. It stretches out by the reciprocal. So let's say makes it twice as wide. So we're going to do horizontal stretch, actually. And we're going to write down twice as wide. We're going to move that in the horizontal direction. So let's do this piece by piece. So we need to take this and we need to do a vertical flip. So we're going to flip it upside down and we're going to make it twice as wide. Then we're going to move it down 3. Lots of stuff to keep track of here. So first thing we're going to do is we're going to do a vertical flip. So this point right here would come down here. Then we're going to make it twice as wide. So twice as wide would be, let's see, gosh, twice as wide would get it out here at -8. And then we're going to move it down 3. So we're going to go down 1, 2, 3. So that would be right here. If we were at -2, down 3 would be -5. So this is -8 and -5. So -8, -5. So we'd be right there. Okay, lots to keep track of on this one. Okay, let's do this one. Again, we're going to do a vertical flip. So that means we're going to flip it upside down. So we're going to flip down here. It needs to be twice as wide. If you're on 0, it's not going to go anywhere. And then we need to go down 3. So down 1, 2, 3. So we're going to be right here at -5. So -5 right there. Okay, let's do this one. We need to do a vertical flip. So vertical flip, it'll come down here. We need to make it twice as wide. So instead of being at 2, we're going to widen it up and we're going to be at 4. And then we need to move down 3, remember. So 1, 2, 3. So we're going to be right here. 4, -4. So let's do 4 and -4. So that's going to look like this right there. And then let's see what we've got here. Last one, we're going to do a vertical flip. So that's going to flip it upside down. That's going to be at -4. We're going to make it twice as wide. It was at 3. It was 3 away from the y-axis. The x-coordinate was 3. Now we're going to double that. So it's going to be at 6. And then we're going to move it. Remember, we said down 3. So that would be down 1, 2, 3. So this is going to be at 6, -7. So let's go 6 and -7. Oh boy, let's see. We're off the charts just a little bit here. So we'd be about right there. Okay, so let's go ahead and see here. Let's connect those and let's see if this doesn't make sense. Okay, does this look like it was flipped upside down? Yeah, it kind of had this cup shape going up. Now we've got this cup shape going down. Does it look like we moved it down 3? Absolutely. And does it look like it's been horizontally stretched out? Is it wider, longer than it was before? We started here at -4 on the parent graph. Now we're starting at -8. We ended here at +3, and now we're ending over here at +6. So that looks pretty darn good. Again, lots of weird, funky transformations going on here with these piecewise functions. But if you can follow this both coordinate-wise and graphing-wise, then you're in pretty good shape. Okay, let's slide down here, and I believe this gets a little bit easier here. So it says g of x equals x is the parent function of all linear functions. Remember, that is the basic linear function. Write a new linear function given the description. So we want to reflect this over the x-axis. So remember, the x-axis goes here, so we want to flip top for bottom and bottom for top. So that's a vertical flip. And then we want to move it down 2. So we're just going to write down y equals. To vertically flip this, we put a negative in front of the x. And then if we want to move it down 2, that's just that normal subtract 2 because this is all after the function made the shape. So there we go. All right, next one. Vertically stretch it by a factor of 5 and then translate it up. Vertical stretches and vertical shrinks are pretty easy because they do exactly what we'd think. So we're going to multiply that function by 5. That's going to make it 5 times steeper. And then we just want to translate it up 4 units. So we're going to go +4. Again, pretty easy on the 2 of those. And then it says translate left 4 units and up 6 units. So if we do something like that, remember this is horizontal, so that does the opposite of what you'd think. So we're going to need a set of parentheses. If we want to go to the left, we actually add 4 to that. Because remember, that's going to make the graph 4 units sooner. That's why it moves to the left. And then we want to move up 6. So we're going to put a +6 right here. All right. There we are. Now, this is a parent function of an exponential, and we want to do these three transformations to it. So let's go ahead and take a look here. Down 6 and left 5 units. So on this, gosh, that's pretty easy. No vertical stretches or shrink. Translation, sliding things around are pretty easy. So we're going to do 4 to the x, and if we want to move it down, we're just going to subtract 6. And if we want to move it to the left, remember you'd think you'd subtract, but we don't, we add, and we're going to add 5 in the exponent. If you wanted to, you could put parentheses around there. That would be totally okay. All right, let's take a look. Vertically shrunk by a factor of 1/3. Remember, vertical changes are pretty easy. And then translated 5 units up and 2 units to the right. Okay, so let's see what we'd have here. If we vertically shrink this, we're going to take that original graph and we're going to multiply it by 1/3. Now, if you wanted to put that in parentheses, you could. I'm going to go ahead and leave that dot right there. And then we translated up 5 units, so we're going to add 5 to this, and we want to go 2 units to the right. So if we want it to move to the right, again, we've got to do the opposite here. So that means we're going to subtract 2. All right. And then the last one, vertically flip and then translate up 3 units and then left 2 units. So if you want to vertically flip something, you just take that function, that plain old function, and we put a negative in front of it. That's going to flip it upside down. Up 3 units, of course, is going to be plus 3. And then if we wanted to, let's see, left 2 units. Left, you'd think that would be subtract. It's not. It's going to be the opposite. So we're going to add so we can make that shape sooner. So there we go right there. Okay. All right, let's take a look at the other side. Okay, on this back side, it says describe the transformation of the parent function f of x equals x. So that's that standard old linear function. Sketch the graph of each transformation. Be sure to graph and label 3 key points for each one of these. Okay, so let's go ahead and take a look at what happens here. We don't have any sets of parentheses, so these are both vertical changes. This is a vertical flip and stretch. Vertical flip and stretch because we've multiplied it by 2. This is going to be twice as steep. 2 times taller / steeper. Okay, and then this is just going to move it up 4 units. So here's what we're going to do. We're going to take the original one, and I'm just going to put these dots on here for the original one. Remember, right at the origin, and then over 1 and up 1, back 1 and down 1. And then we're going to take this and we're going to vertically flip it and we're going to make it 2 times taller. So instead of going over 1 and up 1, we're going to go over 1 and down twice as far. Okay? We're going to go back 1 and up twice as far. So it's going to look something like this. And then we just want to move it up 4 units. So we're going to go up 1, 2, 3, 4. So we're going to be right here. And again, over 1, down 2, over 1, up 2. So the graph is going to look something like this. So we're going to draw that nice and straight and put arrows on the end, and then we want to label these. So this point right here would be -1, 6. This point right here would be 0, 4. And then this point right here would be 1, 2. And we're all set. That's all there is to it. Let's take a look at this one right here. This is a vertical stretch. So vertical stretch. Whoops, stretch. And I'm just going to say factor 3. So that'll tell us that it's 3 times taller. And then this is going to be down 5 units. So the original one, again, would look like this. Origin, and then over 1 and up 1, back 1 and down 1. What we're going to do is we're going to vertically stretch this by a factor of 3. So we're going to go over 1 and we're going to go up 3 times as far, so about right there. We're going to go back 1 and down 3 times as far. So we've got this 3 times as steep as it used to be. And now we're going to slide this down 5 units. So we're going to go down 1, 2, 3, 4, 5. So we're going to put that center point right there. And then over 1, up 3 times as far. Back 1, down 3 times as far. So this is what it would look like. Got a graph that looks something like this. Again, draw that as straight as you can. We'll put arrows on here. And then these are the points that we want to label right here. So this one is 1, -2. This one is 0, -5. And this one is -1, -8. Okay? All right, let's take a look at this one. This one has a set of parentheses in it, so that means the x was changed before it made this shape. So subtracting 2, again, you'd think that would move it to the left. It's not going to move it to the left. It's actually going to move it to the right 2 units. And this is going to be a vertical stretch. So I'm just going to write v stretch by factor 4. 4 times as tall as it used to be. So we're going to take that original shape, okay, whoops, change colors here, this one right here, over one and up one, back one and down one, that perfect 45 like this right here. And we're going to take this and we're going to make it 4 times taller. So we're going to go over and we're going to go up 4 times as far, back, and we're going to go down 4 times as far. So this is what our shape looks like. And then we're going to move it to the right 2. So we're going to go 1, 2. So here's like that middle part. And then again, we're going to go over 1 and up 4. We're going to go back 1 and down 4. So here's what the graph would look like. Okay, make that nice and straight. Looks pretty good. Arrows on the end. And then let's label these key points. These were the ones that we moved. So this is, let's see, what would we have here? 2, 0, 1, -4. And this one would be 0, -8. Okay, so those are the key points there. I do want to come back here and I want to point out one thing. Again, these are the 3 points that we're going to want to see graphed and labeled on the test. But if you were to come back here and just double check this, this would be y equals, if I distribute through, this would be 4x and this would be -8. That's in slope-intercept form, and you can tell that this would cross at -8 and have a slope of 4. There we go right there. This is what they meant. They wanted us to have a horizontal transformation, a horizontal slide, a shift, a translation to the right 2. But the net effect of this is we get the same shape, this steep line right here. That's the same as sliding it down 8 units, a vertical transformation there, a vertical slide there. Okay, again, just an extra little point right there. Okay, slide down here. Let's take a look at the next part. These are exponential functions. It says describe and graph the transformation of the exponential function. Again, be sure and label the 3 key points and the asymptote for this one. So I'm going to underline that so that we don't forget that. We've got a basic shape of 3 to the x. So again, I'm going to write down what those points are because we're going to use these over and over again. Look how nice they were here. -1, 0, and 1. This is always a 1 for any exponential. And then remember, the negative in the exponent means reciprocal, so this would be 1/3. Any number raised to that 1 power is going to be that same number, so it's going to be the base. So -1, 0, and 1, that's always going to be a 1. This is 1 over the base, reciprocal of the base, and that is the base. So that's going to be our basic shape here. So we're going to be like right here, -1, 1/3, 0, 1, and then 1, 3. So that's our basic shape, and then the horizontal asymptote would be y equals 0. Okay, so that's what we've got, and now we want to take care of the transformation here. So what happened here was they took the x and they added 4 to it, and again, because that's in parentheses, we could put, if that's in the exponent, we could put parentheses around it. Adding 4 to the x actually moves it in the opposite direction, so this is going to move it to the left 4. So we're going to take, that's the only change here, we're going to take every one of these points and we're going to move them to the left 4 units. So we're going to go 1, 2, 3, 4. So we're going to put a point right there. 1, 2, 3, 4. We're going to put a point right there. And 1, 2, 3, 4. We're going to put a point right there. Now I'm going to blow this up just a tad so we can kind of tell what's going on here. So this is what it would look like. It would run along here, and then again get closer and closer and closer to the x-axis. There's our asymptote of y equals 0, and then let's label each one of these. So this point right here, it was -1, 1/3. All we did was move it back 4 units. So that's -5, 1/3. This one right here was 0, 1. We moved it back 4 units, so this is going to be -4. So that one right there is -4, 1. And this one we moved back 4 units. We didn't change the y value at all. So this is -3, 3. Okay, so we've got those labeled and we've got the asymptote labeled. So we're in good shape there. Same 3 key points. Now we're going to take these and we're going to do a vertical flip. So vertical flip. We're going to flip it across the x-axis, and then we're going to move this up 4. So instead of having these key points right here like that, we're going to take this and we're going to do a vertical flip. So this one's going to be upside down here, so it's going to be there. Whoops, let me do that in red. Okay, this one, instead of being at 0, 1, we're going to be at 0, -1, and this is going to be 1, -3. And then we're going to take that and we're going to move it up 3 units. Now, remember, the horizontal asymptote, the asymptote out on this end was y equals 0. But if we take that and we move everything up 4 units, this is going to become y equals 4. So we're going to have an asymptote out here of y equals 4. Now, this can be really helpful because that's going to help us make the shape of the graph here, because we're going to move this up 4 units. So we're going to go up, count very carefully, 1, 2, 3, 4. We're going to be about right there. That looks pretty good. Then we're going to go up 1, 2, 3, 4. We're going to be about right there. And up 1, 2, 3, 4. So we're going to be about right there. So again, that horizontal asymptote, that asymptote out here helps us draw this. So we're going to run along here, and we're going to hit all of these points right here. And again, that's going to be really steep, grow in that direction. So we'll put arrows on here. And then we want to label these 3 points. We'll do the easy one first. Okay, this one right here is right on that convenient point. That's going to be 1, 1. This one right here, also an easy point. This is going to be 0, 3. And this one right here, this is back 1, so it's -1, something. And remember, we went up 1/3 of a unit, so that was 1/3. We went down 1/3 right here, and then we moved everything up 4 units. So it's going to be 1/3 less than 4. So if we do 4 minus 1/3, that's going to be 3 2/3. And I'm totally okay with you leaving it like that. If you wanted to write it as an improper fraction, this would be -1, let's see, that would be 11/3. Okay, either way would be totally fine, but we've got the asymptote, we've got the key points on there, we've got them labeled and stuff like that. So we're in pretty good shape there. Let's take a look at this last one. Same basic shape, but now we want to move it, let's see, with the x there, that's going to move it right 5. Does the opposite, so right 5. And this is going to move it up 4, okay? So we're going to take that same shape, so let me put those on here. This one, and this one. So the -1, 1/3, 0, 1, and then the 1, 3. And we're going to move it right 5 and up 4. So right 5, 1, 2, 3, 4, 5, and up 4. 1, 2, 3, 4. So right here. Whoops, let me do that in red so we know we've got the answer right there. And then we're going to go right 5 and up 4. 1, 2, 3, 4, 5. 1, 2, 3, 4. Okay. Now look at how they kind of have the same relationship over here. That looks good. And then we're going to go right 5. 1, 2, 3, 4, 5. And up 4. 1, 2, 3, 4. Now notice that we're a little bit above the x-axis here. So we're going to be a little bit above. Little bit above, little bit above, just a little bit above right here. And remember, if we're moving it up here, that's going to change the asymptote. The asymptote was right here. Now the asymptote is going to be over here again at y equals 4. So we're going to run along this asymptote, okay? And then we're going to hit these 3 points right here and then grow really quickly, put an arrow on that, and I'll make that nice and fat, and then we're going to label each one of these. Okay, this one's not too bad. 6, 7, 6, 7. This one is 5, 5, 5, 5, and then this one right here would be over 4, and we're up just a little bit more than 4. Remember, this is up above there 1/3, so this is going to be 4 1/3. And again, if you wanted to write that 4, and this would be, let's see, that's 12 plus 1, so that'd be 13/3. Totally okay. All right, but that's the way that one would look. We've got there everything graphed there, labeled, asymptotes and everything. Now it says describe the transformation. So these hopefully will be pretty easy. All we have to do is say, look, they started off with f, and then they made a new function by transforming this somehow. So it says describe what happened from f to g. So again, hoping these are pretty easy because we've been doing this kind of all along here. This is a vertical stretch. So vertical stretch, factor of 3. And this is going to move it, let's see, that's a vertical shift. That's going to move it down 2. On this one right here, again, a linear function right here. So what happened here is it's inside parentheses. So this is going to move it to the, let's see, that's going to be to the left 1. And this is going to be 4 times taller. That's a vertical stretch. We could say steeper. Again, lots of different ways to write these down. And as long as it's very descriptive and accurate, then I'm okay with that. Let's take a look at this one. We've got an exponential. The only thing that changed from f to g is they added 3 to the x. So that's going to move it to the left 3. Let's see, exponential here. Oh, they added 3 again, but then they subtracted 1. So how's that going to change it? This is going to do the same thing. This is going to be left 3. Again, opposite with the x when we change it horizontally, but when we change it after the shape, this is going to move it exactly where we think it would. So this is going to move it down 1. All right, this one's kind of interesting. Notice that we've got a negative in front of the x. That is a horizontal flip. Okay, so horizontal flip. That's right 4 left. So let me show you what that would look like. If the normal exponential looked like this, we would flip everything to the other side. So it would go like that. We'd have a horizontal flip. It would flip across the y-axis. Okay, and this would go, let's see, up 6. So we'd flip it around and then we'd move it up 6. This one right here, notice that this is outside, so that's going to be a vertical flip. Vertical flip. Okay, so again, if it looked like this, we're going to flip it upside down. You can tell the difference between this is a vertical flip, we're flipping top for bottom. Here, this is a horizontal flip, we're flipping right for left. And then this is going to move it down 4. So we'd flip this upside down, and then we'd move down 4. And then let's take a look. Oh, it looks like we're back to linear functions right here. So let's see what happened. This is going to be a vertical stretch. Vertical stretch. Twice as tall. And I'll put that over here. 2 times taller / steeper. And this is going to move it, think for just a second, we're changing the x, so that's going to move it to the right 1. And that +5 is going to move it up 5. Make that look like a 5. All right, and then the last one here. This one's inside with the x, so this is going to change it in the opposite direction of what you'd think. So this is going to move it to the right 3. So because this is outside, this is going to be a vertical shrink. We're going to multiply all the y values by a half. So this is going to make it half as tall / steep. It's not going to be as steep. Okay. All right. Really good problems there. Again, the practice test is normally longer than the test. We'll see if that works out on this one. Lots of good stuff there. Again, if you can learn how to do these transformations, whether graphically or with the coordinates, lots and lots of good stuff here that's going to serve you well in the future. Good luck on the test.